Right. We are going to be concentrating on the paper which was written in 2017, grade 11, November 2017. It was a national paper. So we are on question 5, trigonometry. First part is saying simplify fully sine 90 minus x cos 180 plus x plus tan x cos x sine 80. So for us to do this, we need to understand the cast diagram. We need to understand the cast diagram. So our cast diagram, this is first quadrant, second quadrant, third quadrant, fourth quadrant. Here we have 0 degrees. Here we have 90 degrees. Here we have 180 degrees. Here we are having 270 degrees. Then here we are having 360 degrees. So these are the positive angles. If we take the negative angles, here it means we are having negative 360 degrees. Here we are having negative 90 degrees. Here we are having negative 180 degrees. Then here we are having negative 270 degrees. Then when an angle is going in a clockwise direction, in an anti-clockwise direction, it means the angle is positive. And when an angle is going in an anti-clockwise direction, it means the angle is negative. So here we are going to identify 90 minus x. So we go at the terminal. 90 minus x means we are going this side. So it means we are going to be in the first quadrant. And sorry, we have to know that in the first quadrant, all the trig ratios are positive. In the second quadrant, it's only sine, which is positive. Then in the third quadrant, it's only tan, which is positive. In the fourth quadrant, it's only cos, which is positive. So, answering this question, answering the first question, we are saying answering the first question there. So we are saying our 90 degrees, it's here minus, we are going to go, we assume that our x is an acute angle. So if we say 90 minus, we end up in the first quadrant. What is the sign of cos in the first quadrant? So it means this one will result to, we are on, it's going to be first quadrant. What's the sign of sine in the first quadrant? Is positive, but because of 90 degrees is a trig ratio, changes to cos. So that one changes to cos x. Then we say multiplied by 180. Here it's our 180. 180 plus, so 180 plus anti-clockwise direction. We are going to be in the third quadrant. We are going to be in the third quadrant. And what is the sign of cos in the third quadrant? It's negative. So here it's going to be negative cos x. Then saying plus tan x here. The identity for tan x is going to be sine x over cos x. Then we are going to multiply that by cos x. This is the same as cos over 1. Then we are having minus 180 degrees. Minus 180 is here, this terminal. Then it's saying plus x, which comes here. So we are in the third quadrant. What's there in the third quadrant? Sine is negative. So this one becomes negative sine x. Then we have to simplify that. So our final answer is gonna be equal to cos squared x, which is negative, which is this, and this is gonna be negative. Then it's gonna be plus this positive and this negative is gonna be negative cos, so it's gonna be negative sine squared x. When you factor out negative, it's negative cos squared x plus sine squared x. And we know the identity for cos squared x plus sine squared x is equal to 1. So our final answer is equal to negative 1. Here, the identity says cos squared x plus sine squared x equal to 1. So it's the one that we applied here to get an answer of negative 1. Then we go to question 2. 5.2 is saying prove without using a calculator that. So we are going to ask ourselves, this angle 315 is in which quadrant? As we can see, it's fourth quadrant. And how do we write an angle in the fourth quadrant? Is 360. From here, an angle can be, in the first quadrant, can be written as theta or 180 not 180, sorry. It's 90 degrees minus theta, then 90 degrees plus theta, or 180 degrees minus theta here, 180 degrees plus theta, or 270 degrees minus theta here, 270 degrees plus theta, or 360 degrees minus theta, then minus theta. So in this case, we are having 315, which is in the fourth quadrant. So it's gonna be 360 degrees minus 45 degrees. And we know sine in the fourth quadrant is negative. So taking this one as our left-hand side. So our left-hand side, you copy as it is. Then it means that is going to reduce it to a negative because we are in the fourth quadrant. Sine is negative in the fourth quadrant. So it's going to be negative sine 45 degrees. Then multiplied by tan. 210 is in which quadrant? 210 here is in the third quadrant between 180 and 270. How do you write an angle in third quadrant? 180 plus. So it means this can be written as 180 degrees plus 30 degrees for this angle. And tan in the third quadrant is positive. So this one reduces to tan 30 degrees. Then we go to the third term. So we are having 190. 190 is in which quadrant? 190 is between 180 and 270. So it's in the third quadrant. Third quadrant is 180 plus. So to get 190, it's gonna be 180 degrees plus 10 degrees. And sine in the third quadrant, it's negative. So it's gonna be multiply here. It's gonna be negative sine 10 degrees all over. We go to the next term. The next term is cos 100. 100 is between 90 and 180, which is the second quadrant. How do we write an angle in the second quadrant? So it's gonna be 90 degrees plus 10 degrees. Then what is the sign of cos? In the second quadrant, we see it's negative because we see 90 degrees. So it's gonna be a co-ratio, meaning to change the cos changes to sine. So it's gonna be negative sine 10 degrees. Then 120. If we check 120, it's gonna be, it's in which quadrant? 120 is between 90 degrees and 180. So it's in the second quadrant. So how do we write the angle in the second quadrant? So it means this can be written as 90 degrees plus 30 degrees. So what's the ratio? What's the sign of sine in the second quadrant? It's negative, it's positive. Here in the second quadrant, sine is positive, but because we are seeing 90, the sign changes to cos. So it's gonna be cos 30 degrees. Then we simplify that. So if we are to check the sine 10 and that sine 10, they cancel out each other. So this will be equal to a negative sine 45. It's going to be a negative root 2 over 2. Then a tan 30 is a special angle. Again, that tan 30, we are going to use the special angles. If we are to check from our triangle, let's quickly check because we are not using a calculator. Want to quickly. It's an equilateral triangle, this one, where here it's 60 degrees, here 60 degrees, here 60 degrees. Can put 2 here, 2 here. I drop a perpendicular. So this will be 1, this will be 1, and here it will be 30 degrees. If we are to apply Pythagoras theorem, we end up having root 3 here. So tan 30 is going to be opposite over, which gives us root 3 over 3. It's root 3 over 3, then divided by cos 30. It's root 3 over 2. If we check, this is the same as root 2, which is negative, over 2 multiplied by root 3 over 3 multiplied by 2 over root 3. So eventually our final answer is a negative root 2 over 3. So we concluded that our left-hand side is equal to our right-hand side. Then we go to the next question. They are saying, in the diagram below, R is a point in the first quadrant such that TOR is equal to alpha, RO is extended to P such that OP is equal to 2RO. So, and TOP is beta. It is given that sine alpha is equal to 3 over 5. And we know sine is opposite over hypotenuse. So if we come to this triangle, we are going to drop a perpendicular here. So we are given sine alpha, this is the angle alpha, and we are told its opposite is 3. So the opposite of alpha here is 3. Then this one is gonna be equal to our hypotenuse, which is 5. So using that, we can calculate the third side using Pythagoras theorem. So it means 5 squared minus 3 squared must be equal to x squared. Then we are getting 16 must be equal to x squared root plus or minus. When solving for x, it can be positive or negative, but depending on the quadrant, it's the one that helps us to get the sign of the value. Since we are in the first quadrant here, our x is positive, so we are going to have our x being equal to 4, which is positive. We applied the Pythagoras theorem here. Pythagoras theorem. Then let's go. What are they saying now? First part is saying without using a calculator, find the value of tan alpha. Find the value of tan alpha. We know from our trig ratios, so tan is opposite of adjacent, so it means tan alpha will be equal to opposite of alpha, here is 3, over the adjacent, here the adjacent gonna be equal to 5. Sorry, the adjacent of alpha is this side, which we determined to be 4. So it means here it's gonna be equal to 3 over 4. Then the next question is saying, find this value of sine beta. You want the value of sine beta. But if we are to check from what is here, beta is from here to that. So if we are to check our beta, will be equal to, since this is a straight line, it's 180 degrees, plus this part, it's what? It's alpha. So our beta is equal to 180 plus alpha. Therefore, it means that sine beta will be equal to sine 180 degrees plus alpha. Then 180 is in which, plus alpha is in which quadrant? It's in third quadrant. What is the sign of sine in the third quadrant? It's negative. Then it means it's gonna be negative sine alpha, which is equal to negative sine its opposite, which is 3, over hypotenuse, which is 5. So eventually our answer is negative 3 over 5. It was possible to apply. Here you are told that OP is 2OR. So it means we can say that OP here will be equal to 2 times OR. OR we said it's 5. So it will be equal to 2 times 5, which gives us a 10. Then drop a perpendicular here. Then as you can see, this triangle here, sorry, as you can see, this triangle here, we can say OP M, I can call this point M. OPM will be similar to triangle ORT. So since here we multiplied by 2, this can be also multiplied by 2 to end up having 6y. Then this also multiplies by 2, end up having 8. But because it's on this other side, it means it's going to be a negative. And this one, because it's in this other side, it's gonna be negative. So using this, it was possible that we can still calculate this angle. It's gonna be equal to sine beta, which is opposite, minus 6 over hypotenuse, which is, see, in this triangle, minus 6 over 10. So it was possible to be like that. Then saying calculate the coordinates of P. Calculate the coordinates of P. So if you were to use this method, so how do you answer that one? Let us answer that one. It means the coordinates of P, we are just going to use similarity. So we are going to say triangle PMO, PMO is similar to triangle RTO. RTO, considering that T is taking that T will be the foot of that. This is question 5.3.3. So if those two are similar, why are we saying those two triangles are similar? If we check, we have got that angle at T, or we are saying angle PMO is equal to angle RTO. The reason those two are both equal to 90 degrees. Then our P our MOP is equal to our TOR these are vertically opposite angles. So these two triangles are similar. Since we have proven that these two triangles are similar, we can use the ratio of their sides now. So we can now say P, we can now say OR divided by, so let me use OP divided by OR must be equal to MO divided by TO. So OR we know is 5. Then the other one we are told is 2 times OR, which is equal to OP, sorry. It's 2 times. So it's supposed to be 10 over 5. That must be equal to OM over TO. Which is 4. So OM is 8 units. But because we are in the second quadrant, it means our P, this X value must be negative. So we end up having negative 8. Then we apply the same ratio, 10 over 5. Remember here, it's also equal to MP over TR. What is the reason for this? Those two triangles are similar. PMO similar to triangle RTO. So this will be equal to MP, which we do not know, over what? MP over RT, which is 3. When we simplify there, it means our MP will be equal to 6. Because we are in this quadrant, where y is negative, our y gonna be negative 6. Like that. Okay. Alternatively, it was possible that for us to calculate that, we were just going to come here. We want the coordinates of P. Then we say let the coordinates of P, let the coordinates of P be xy. Let the coordinates of P be xy. So we now have that xy. So it means here it will be x, here it will be y. Then from there, in this triangle, we can write sine beta is opposite, which is y, divided by 10. So sine beta is equal to y over 10. But we know sine beta is negative 3 over 5. So we simplify here. We get our y equal to negative 6. Then we have to calculate cos beta, which will be equal to x over 10. But if we are to use this triangle, knowing that cos beta can be written as, knowing that our beta is 180 plus alpha, it means cos beta will be equal to cos 180 degrees plus alpha, which is equal to cos alpha, because we are in this third quadrant, it's negative cos alpha, which is equal to negative cos alpha is adjacent, so negative 4 over 5. So we were going to equate this to negative 4 over 5. Then from there, our x is equal to negative 8. Therefore, eventually our coordinates of P are going to be negative 8, negative 6. Then we go to the last question, 5.4. They are saying prove the identity. So to prove this, we are just going to concentrate on the left-hand side. So our left-hand side, we are going to have left-hand side equal to that one. So we are going to have sine theta minus tan theta. It changes to sine theta over cos theta multiplied by cos squared theta. This is the same as over 1, or divided by cos theta minus open bracket 1 minus sine squared theta. But we know there is the identity which says sine squared theta plus cos squared theta equal to 1. When we take this one to that side, it means 1 minus sine squared theta will be equal to cos squared theta. So that's what we are going to substitute there. So this one reduces to sine theta minus sine theta. This one and the other cos are going to divide. So this one, we are going to have cos theta all over cos theta minus cos squared theta. This is going to reduce to sine theta on our numerator is common. We have 1 minus cos theta all over, on our denominator cos theta is common. Then we are left with 1 minus cos theta. 1 minus cos theta is common, so they are going to divide. You are going to be left with sine theta over cos theta. Sin theta over cos theta is equal to tan theta. We have proven that our left-hand side is equal to our right-hand side. Thank you.